In the last video, we looked at working with the graphs of functions. We're now on the last topic for this section, which is working with the formula for the function. And a lot of pre-calculus and calculus is about the connection between the formulas and the graphs. And sometimes it's easier to do problems with the graphs, sometimes it's easier with the formulas. Sometimes we only have a formula, we don't know what the graph looks like, or vice versa. So we want to make sure that we understand how to do things both ways and always look for the connection between the two methods. Okay, so I've got basically 6 problems. I put the first 2 up on the board here. That's what we'll work through in this video. And for each function that you're given, I'm asking 3 things. Give me the domain in interval notation, find me the y-intercept, if there is one, and then find me the x-intercept or intercepts. And just make a note here, I say or the t-intercept or intercepts, because you'll notice sometimes I'm calling the input of my function x, sometimes I'm calling the input of my function t. When I'm doing that, then I would have a t-axis and a y-axis instead of the horizontal axis being an x-axis. That's something that we'll see very often in applications, because often we're going to let our input represent a time, and then we usually call it t rather than x. Okay, so basically I've got 2 problems, but each one has 2 parts. What I'm going to do is I'm going to work through the functions that I have on the left side of the board here and answer these 3 questions, and then I'll have you pause the video and work out the functions that I've got on the right side of the board. If you've got the worksheet, it's the left side of the worksheet and the right side of the worksheet. Okay. So when we're asked what the domain is, that's the set of all possible inputs, everything that we could plug into the function. So when I look at this formula for the function, I want to say, well, what am I doing to x? And very often when I'm trying to figure out what the domain is, which is what I can plug in, I'm going to sort of think more negatively. I'm going to think, is there anything I can't plug in? So what I'm doing to x here is I'm multiplying it by 3, and then I'm subtracting 2. I can do that with any number. Give me any number you want, I can multiply it by 3. I can subtract 2 from the result. So the domain here would be all real numbers. There are no restrictions on what I can plug in. And if I give that in interval notation, that's going to be everything from negative infinity to infinity. All right, then we're asked to find the y-intercept. Now, I want to think of this, even though I'm going to do this algebraically, here's a place where it's helpful to think of it graphically as well. If I'm at the y-intercept, I'm on the y-axis. If I'm on the y-axis, my x value is 0, because I haven't gone to the left or to the right. So I know that I'm going to have, intercepts are always points, so it's going to be an ordered pair. The x value of the y-intercept is always 0. I'm going to find the y value by plugging in 0 to the function. So I can put my, let's get a different color for this. I can put parentheses around x here. That's just a placeholder for my input. So we're going to have 3 times my input minus 2. I'm plugging in 0. 3 times 0 is 0. Minus 2 is negative 2. So that negative 2 is what I'm going to put right here. So my y-intercept is 0, negative 2. And then part C, we're asked to find the x-intercept or septs. Okay. So again, I want to think of that graphically, because that's going to be where we cross the x-axis. And if we're on the x-axis, that means that our y value is equal to 0. So this is a formula that gives me the y value for my function. So I'm going to set that equal to 0 and solve for x. So we'll have 3x minus 2 equals 0. And again, if I'm finding the y-intercept, sorry, the x-intercept, that's going to be a point. It's an ordered pair, so the y value will be 0. I just have to solve for what the x value is. So I set the formula for the y value equal to 0. I'm going to add 2 to both sides. So 3x equals 2. divide both sides by 3, and x is 2/3, and that goes in the x position right there. Okay. So the x and y intercepts are ordered pairs. The y-intercept, we're on the y-axis, so the x value is 0. X-intercepts, we're on the x-axis, so the y value is 0. So in one case, you're plugging in 0. In another case, you're saying, what do I plug in order to get out 0? All right, so let's repeat this problem now with this first question from question 2. So if I look at this function, I'm calling my inputs t's now instead of x. Okay. What am I doing to t? I'm subtracting 2, and then I'm squaring it. Well, neither of those has any restrictions. I can subtract 2 from anything. I can square anything. So once again, my domain is going to be all real numbers, everything from -infinity to infinity. To get the y-intercept, again, that's going to be on the y-axis, which means that my input has to be 0. Now in this case, my input is t rather than x, so I'm just going to plug in 0 for t. So it would become f of 0 is equal to, and again, I can just copy the formula for that function, replacing t with a placeholder for my input. And what I'm plugging in as my input is 0. So 0 minus 2 would give me a -2 squared. Notice I'm squaring the whole thing. So that's -2 times -2, which is going to be +4. So that's the y value of my y-intercept. The y-intercept is a point. It's an ordered pair. T was 0, y was 4. All right, excellent. To get the t-intercept, now this time it's the t-intercept rather than the x-intercept, simply because we're calling our inputs t. I know that's going to be, again, an ordered pair. But my y value, the output's going to be 0. And there might be more than one of these, I'm not sure until I solve. Or there might be none, I'm also not sure until I solve. But basically I'm saying, what do I plug in to get out 0? So I want t minus 2 squared to equal 0. So I can take the square root of both sides. So the square root of t minus 2 squared is the square root of 0. So the absolute value of t minus 2 is equal to the square root of 0, which is 0. Now, usually when I have an absolute value, that gives me 2 options, but they would be plus and minus whatever the number is on the right side. Here, plus and minus 0 are exactly the same thing. They're both just 0. So I get t minus 2 is equal to 0, which means t is equal to 2. So that's the input that gives me my output of 0. Put those pieces together, and the t-intercept is 2, 0. All right, so I've worked through the left-hand version problems for problems 1 and 2. The right-hand problems are similar. I just wanted you to have a chance to practice those. So same 3 questions for each of those. Find me the domain, the y-intercept, and for this problem, since we're calling our input x, the x-intercept or septs. And for this problem, since we're calling our input t, the t-intercept or septs. Then tune back in and we'll go over the answers. All right, I've got the answers up here. I've just rearranged the board a little bit. So our first function was g of x equals 4 minus 5x. Domain here is all real numbers, so the interval from -infinity to infinity. Y-intercept of 0, 4. X-intercept of 4/5, 0. Second function was g of t equals 3 plus 5, the quantity 5 plus t squared. Again, the domain is all real numbers. The y-intercept 0, 28. The one problem that I want to go over is part C, because there is no t-intercept for this problem. Remember, if I were finding the t-intercept, that's going to be where we cross the t-axis, so that would mean the y value was 0. So we take the formula for my function, 3 plus 5 plus t quantity squared, and I would set that equal to 0, and then I'm going to solve for t. And then I would put that into an ordered pair. Y is 0, and whatever solution I get for t becomes the first coordinate. But if I look at this, before I try to undo the squaring, I would subtract the 3 over. So we get 5 plus t squared equals negative 3, and that's not possible. Because when I square something, it becomes non-negative. So the left-hand side of this equation is not negative, the right-hand side is negative, there's no solution. So if there's no solution to this, that's going to mean that there is no t-intercept for this particular function.